Very good. Welcome, everyone. This is George Demarest from Aerospike, and this is the webinar, the Office Hours webinar, What is New in Aerospike Database 7.1? And with me is Director of Product for the database, Ronen Botzer, and we're going to talk about the release that was announced on May 15th, just last week. There is a press release live, and the news is out there. So this is a follow-on webinar to go into a bit of detail on the new features and to take any questions that you might have. And please, whenever you have a question, please use the Q&A feature or the chat to get in touch with us, and we'll answer the questions as they come in. So not a lot of messaging and spin. This is really about the product. And what we'll cover is just an overview of the announcement. We'll talk about some in-memory caching technology that we've introduced with 7.1, some storage optimizations that enable real-time performance on very low-cost cloud storage. And then finally, a group of other projects. Any Aerospike release has dozens of projects, big and small, but taken together, we've worked a lot to improve the operation and the support and the problem resolution for the product. So we'll cover those areas, and as I said, as you have questions, please feel free to ask. We're happy to answer them. So first, in terms of what this release is about, it's, as I mentioned, it's somewhat about cache. We have introduced a new cache eviction strategy, and we want to become a better cache. We already function with some major customers as a cache, but the new cache eviction strategy opens up a lot of additional interesting use cases as an in-memory cache for Aerospike. The other area is in support for NVMe-compatible block storage over a network. So that could be a network-attached storage, or it could be a cloud storage service like AWS Elastic Block Service. And that enables some interesting new deployment options, if you will, different price points. Aerospike is about real-time performance, about low latency, high throughput, but also being able to support those kinds of workloads on all different price points, all different configurations in the cloud, in on premises. So it's always about providing more options for how to run and hopefully making it faster, making it easier, and making it better for developers. Those are kind of our goals for these releases. It's also because we are in the cloud era. We released Aerospike Cloud last year, and it's a big part of our future. So adopting cloud native design principles that take advantage of the unique capabilities of public clouds or hybrid clouds or multi-cloud. That is part of our mission as well, and then to make it easier to own, easier to operate. And that's what 7.1 is about. Before we go into the individual features, I think it's important to understand where 7.1 fits in our overall release strategy. So this is the first question I'm going to put to Ronen. So Aerospike has major release numbers, Aerospike 5, 6, and now 7. And 7.1 is part of 3 releases that are moving towards a very important goal, and that is multi-record transactions. But Ronen, can you kind of characterize where this release fits in the evolution of Aerospike?
Sure. So like you mentioned, we have major themes in these under these major releases. So Aerospike Database 5 was all about a complete rewrite of our cross data center replication technology for much higher throughput and significant ease of use improvements, being able to dynamically decide on multiple destinations and turn them on and off, and just a lot of configuration that was all changed to be dynamic. Um, so Aerospike Database 6 is mainly around a rewrite of secondary indexes to give them much higher scale, reduce the memory footprint that is associated with them, allow them to be stored in shared memory to support fast restarts of the server. Basically, a ton of flexibility, the ability to put indexes on SSDs or in persistent memory or in shared memory, and getting all these advantages for them. So Aerospike Database 7 builds on that. One of the biggest changes in it is, just like we did the change for secondary indexes and before that primary indexes, the ability to put either of those indexes in one of three storage mediums: persistent memory or shared memory or SSD, right? You could choose that for either of them. Now we're doing the same for data storage, right? So first thing we did in Aerospike 7.0 is a unification of the storage format, which has a lot of advantages that we're going to talk about soon. But one of those things was also the ability to store data itself either in shared memory or in persistent memory or on SSD. So it's just like the other things that we've done under Aerospike, which means you can do fast restarts and still have all the data there and not need to load it from a persistence layer, because it persists through restarts of the daemon, right? So that is like one of the major things we did, and we'll talk about other advantages. But 7.1 builds on that, right? Adds a bunch of cache eviction technology has been improved here, and we'll get into the details of that. But these are milestones, right? 6.4, 7.0, 7.1 are all milestones on the way to support for multi-record transactions. So in previous releases, Aerospike was certified, Jepsen certified as having linearizability, the ability to do linearizable reads under strong consistency. So single record transactions have the highest level of kind of strong consistency guarantees. Now we want to do the same thing for multi-record transactions, support strict serializability, which is a pretty complex thing to do in a distributed system, but we're on the way to do that. And these milestones, while they have their own advantages, part of the work is really just kind of bulldozing and making the way for this new stuff that we're constructing here. I think you're muted, George. Sorry.
Right. And just like in 7.0, we talked, you mentioned the unified storage, but there were kind of some follow-on benefits to that, which made us a better in-memory database. So we've introduced some new caching technology. It makes us a better cache. Is a similar kind of approach with 7.1.
Yeah, I think shortly we're going to dig into that, but both 7.0 and 7.1, their big advantages are in the in-memory storage space. So whether you are configuring Aerospike to be a fantastic in-memory database with a ton of advantages, those advantages also work with using Aerospike as an in-memory cache. They're kind of tightly linked. These features, it's more of a configuration difference. So one of the great things about Aerospike is the ability to configure namespaces to behave in very different ways and do multiple namespaces with different configurations in the same database cluster. So if you needed to serve applications from the same hardware, basically, some of them basically for system of engagement, where you want high availability more than you want consistency, right? So it's a distributed system under CAP theorem. You want to do an AP mode, right? High availability mode versus a CP mode, which is what we provide strong consistency for. So you can have a system of engagement. You can also have another namespace that is configured to, never lose writes under any condition and not getting any inconsistencies. And that would be configured for strong consistency. And let's say those two namespaces store their data on SSD. Now you can also have an in-memory database there serving other applications that is stored in memory and has a persistence layer on SSD. But you may also want to have some applications to be able to use an in-memory cache that maybe doesn't use any disk at all. It's just purely in memory. All of these features are leaning on the things that we did in both 7.0 and now additions in 7.1. George, sorry, you're muted.
Sorry. So let's get to the caching in 7.1. The You mentioned the cache eviction strategies, and we've actually been used as a cache by lots of different Aerospike customers, but this is really a new kind of changes the game a bit. And you talk about precision cache eviction with precision LRU cache eviction. What is that?
Okay, so what we have so far that is used heavily is the ability to do evictions based on the expiration, right? So when you take a record, and let's say you're not in a strong consistency kind of namespace where typically people don't use TTLs, but you're in an AP mode namespace, used for high availability type, systems of engagement, for example. In those cases, typically people will use TTLs on the record. So when you set a TTL on a record in a write operation, it basically gives it it takes the TTL, so let's say it's 5 minutes, and adds it to right now, and basically creates an expiration time for it, which is now plus 5 minutes, right? So when an eviction threshold is crossed, and that could be we're running out of memory, or we're running out of disk, or there's a few triggers that can kick off evictions that basically are a sign that we're starting to run out of space. And what happens under evictions, what we had so far is an eviction policy that it was associated with expiration. Okay, it was like similar to volatile TTL and Redis. Basically, at that point, the records that are closest to their expiration date are going to be tossed out first. Okay, so we're basically saying, they're anyway going to expire soon, so we might as well expire them early. And the way we do this is through really precise bucketing of all the expiration dates. And Aerospike, you can control this. You can have 100 buckets, 1,000 buckets, 10,000 buckets. So let's say you had 1,000 buckets. If eviction threshold crosses, it'll start throwing basically the ones that are nearest to expiration. At least that was the previous eviction policy. 0.1% of the data will just be tossed out. And then the next 0.1% of the data, and the next 0.1% of the data, until we are under the eviction threshold. All right. So that's the way that specific eviction policy works. And it's just very precise. Whereas what Redis would do is when they have an eviction threshold and you're using LRU, they start doing sampling of records. They look ahead, they sample a certain number of records, and then they evict the ones that are the least recently used among those. Now, that is not precise at all, right? On a whole, it's roughly okay, because you'll keep doing it. You'll have another sample and toss the ones that are, least recently used there, and then move on and keep doing it. But then you may stop, and you actually will have records that have been evicted. And then when you stop, all the records that are kind of to the right of there still might be ones that are, better candidates for eviction that you missed because you were sampling. Whereas in the case of Aerospike, we have a lot of precision because all this metadata is always kept in these buckets and adjusted anytime you update the record. So you don't get the situation. It really is across the entire namespace that the data is being evicted, and it's kind of known in advance. So it's very quick and very precise. Now, in the case of the new LRU eviction policy that we have, they actually combine together. What we do is you have the ability to configure either for the namespace or at the set level, which is like a table in Aerospike, or coming from the application, you can say that if a read is within a certain percent of expiration date of that record, then we will touch it and move it. We will give it a new TTL automatically on this read operation. So let's say you had all the records roughly had 10 days of time to live. And we configure this threshold, read touch TTL percent to 90%. That means that for a day, no reads are going to make any change here. When we are 9 days away from expiration, 90% or 9 days in this case, the first read that shows up will actually extend the TTL, the eviction, the expiration of this record by whatever it had before. So it looks quickly and calculates a new TTL by the difference between the expiration date and the last update time, finds out that it's 10 days, and it'll move it 10 days now into the future. So it'll basically, and that gets communicated to the replicas and it gets persisted to disk. But this is the only read that actually caused anything to happen. So it's very efficient, first thing in terms of resources. We're not like turning every read into a write operation. It is still precise enough to not lose any information. Now, if I do a rolling of the cluster nodes, the replica remembers that this thing happened. And even if I take this node down, this read that touched, kind of touched the record into the future, this information will be retained. So it's very efficient. It's very precise. It is persisted in a way that I don't believe Redis actually persists this information, because they have, only updates that actually get written to an append only file, or the RDB snapshot plus the append only file. So, when you're restarting a node in Redis, this information is reset. Whereas in Aerospike, if I restarted the data, I do not lose this information. So it's a combination of reads with the kind of expiration policy to really give you a very efficient, very precise LRU behavior that is persisted.
So one of Redis is obviously very popular as a cache, and they have been
Mhm.
for a while. We approach the problem perhaps a little bit differently. Being able to, I think the high availability, the kind of the lots of persistence options, lots of deployment options. We are kind of our vision uh, would include something like creating, you could consolidate a lot of caches into a single smaller cluster with Aerospike. You can create a more enterprise grade sort of shared service
Mhm.
of caches. What other advantages does Aerospike have as a cache?
Okay, well, first thing, this cache behavior can be in memory, but you can also apply it to on disk storage, right? So if you did choose to do it with disk storage, you could actually get much higher density, right? With a lot fewer nodes in a cluster, you can have much higher amounts of data in this cache at much lower cost, because the data would be stored on SSD. So it's a choice, right? We make it extremely flexible for the customer. The LRU behavior makes sense that people would use it with an in-memory deployment, but they can also use it with an data on SSD deployment. And it kind of doesn't matter, because they use the same storage format. They have the same advantages. You can use inline compression for either of them. This is especially advantageous when you're doing in memory, because if you have 1 TB of memory space right on the disk, but you have maybe a compression ratio that gets you 50% compression ratio, that means that you can put 2 TB on that 1 TB machine. Okay, so that's a non-trivial advantage. The other thing that we have here is persistence. Whereas Redis puts itself in process memory, and when you restart, that thing evaporates, and you have to now replay everything from an append-only file, or from the RDB, or whatever storage you're using. If you're using Redis Enterprise, right? It needs to actually get reloaded back into memory. With Aerospike, if I'm configuring a namespace to be in memory, it's actually sitting in shared memory segments that work like a RAM disk. So I can actually turn off the Aerospike daemon. Let's say I'm patching it from 7100 to 7102. I could do a rolling upgrade, and the data storage is there. When I restart the machine, all it does is, if there was a clean shutdown, it quickly checks the indexes. The indexes are going to be in sync with the data, and you can get right back to operations within seconds, right? So that is a huge advantage. Number one, because the data is sitting in shared memory, and now you can go through a fast restart, not just of the indexes, but actually of the data itself. And that came in 7.0. Now, the other thing here is that you can actually do an in-memory cache with no disk at all. Because if you think about it, I don't need to load anything from the disk when I'm restarting the database here. So when I restart ASD, the Aerospike daemon, like I said, fast restart here for the data that's sitting in memory, shared memory, the primary index, shared memory storage as well. So what you can do here is it could restart off of a crash even. Let's say you had a crash because of who knows what, out of memory or something. You can restart Aerospike off these shared memory segments even when there was a crash and not actually need to have any persistent storage. It's not filling in over the network. It's not filling in from persistent storage. It's actually just sitting there. Now, if you needed to restart the whole host machine, you could just use just in time the Aerospike shared memory tool and persist those guys to, let's say, EBS, if you're on a compute instance like an R7G or whatever in Amazon. This thing, just in time, you can use the Aerospike shared memory tool, ASMT, and copy it to EBS and then roll the whole machine, use the shared memory tool to load it back from the EBS to shared memory segments, and then do a fast restart. So these are all things that Aerospike allows you to do when you're using it, whether it's in-memory database or in-memory cache. Okay, so in terms of surviving restarts, the speed of restart, surviving, being able to restart off of a crash, all of these things are super nice. We talked about the persistence of things like LRU information, right? It's actually the read becomes a touch operation that is communicated to the replicas, and you're not losing the information related to the reads even. So all of these things, whether you're using in-memory with persistence, like a database, or you're using in-memory without persistence at all, like a cache, you still get great durability and speed and great efficiency. And I think that Aerospike, if people want to try it out, is actually a fantastic in-memory database and a fantastic in-memory cache on top of all the other advantages we talked about. Great efficiency when you're data on SSD, whether you want to use strong consistency or a high availability kind of AP mode.
Very good. Just want to look to see. We have no questions so far. I want to encourage people to ask any questions you might have about the release, but barring that, we can move forward from here and talk about the next major area of development for 7.1, and that is in the area of storage optimization, particularly for network block storage and NVMe compatible block storage. Um, why did we do what did we do and why did we do it, Ronan?
Okay, so Aerospike has always written to disk in these consistent size blocks because that's one of the many low-level optimizations we have around SSDs, where even though we're serving data directly out of SSD, we are competitive with any in-memory database in terms of throughput and latency. So this was an important component of it, but it has a few downsides. So first thing, the write block size, as it used to be, where you had to define a consistent size. It was a static configuration. You could raise it. You can go from 128K all the way to 8 megabytes in these power of 2 kind of increases. You could go from 1 megabyte to 2 megabytes. Typically, the reason you would increase is because the max record was bound by the write block size. Now, so people would increase it, but maybe they would sort of diverge a bit from the optimal size for the disk. So still get pretty good max throughput, but maybe suffer a bit as you needed to grow that. And it was static. You could grow up, but if you wanted to go down, you actually needed to wipe the disk in order to go down and let it fill over the network. Do it node by node like that. Um, it also was less efficient when you had low throughput situations. So there's two ways the data can be persisted to disk in Aerospike, right? We create a streaming write buffer in memory that is the size of the write block size. So, if you set it to a megabyte, you'd have this megabyte buffer in memory. It would start taking records. Either when that buffer was completely full, right? The SWB was completely full, it would flush it, the whole thing to disk, or if you had a timer go off, which is called the flush max MS. So I think by default that is 1 second, it's configurable. But let's say a second has passed and you didn't write fast enough for every device to be filled, right? Every device has its own buffers of the same size that we said. If you had 8 devices and they're 1 megabyte, if you didn't get 8 megabytes a second, you would actually be flushing it kind of prematurely, what is called a partial flush. And we would just pad it all the way to the end and write it to disk. Not a big deal. However, at this point, you might make the block immediately a candidate for defragmentation. So there's some kind of resources associated with it when you are at a lower throughput situation. But the idea was like if you're lower throughput, you still have enough disk I/O to deal with this. However, if you are deploying this on a like NVMe-compatible network attached storage like EBS, let's say you had an in-memory deployment and you used EBS as the storage back persistence for it. Well, in this case, this kind of approach in lower throughput is not ideal because you are still going to be sending a megabyte where maybe you only took 500K in. So what we're trying to do here is to first thing become a lot more efficient with this new design. So the new design basically says instead of having a configurable write block, we're just going to pin it to the maximum size, which is 8 megabytes. And we're going to write in these consistent sized flush size configuration. And we're going to write these units to this. So let's say the flush size is 128K. First thing that's nice is that the flush size is not static. You can configure it up and down dynamically. That's first thing. The second thing is that then now the max write is different and not bounded by this. So you can have a 128K flush size and write, a max record size of 2 megabytes. So it's not a problem. You can take 1 megabyte and write it as several of these flush units, right? Like 8 of them together, end to end, to write this record. Now, let's say we had a lower throughput situation and the timer goes off. The timer goes off now, and it was 128K flush size and 250K came in. So we would write it in 2 of these units. We would have about 8 bytes of wastage at the end, but that's not that bad, right? Like it basically, what it does is it keeps appending these guys until we get to the end of the write block. And only at that point are we done and we can, like, now the write block is immutable and there's no more writes going into it. So what is cool about this thing is first thing, we allow you to still get closer to the most efficient size for the disk. We tend to recommend to people that for the max throughput, use 128K. But before, like we said, really big, if you wanted to accommodate bigger records, you still needed to, increase the write block size. So now the write block size is 8 megabytes. You can go all the way up to there with a max record size, but the flushes will happen in these smaller units. So first thing, on the low end, it's a lot more efficient. We're only putting exactly the bytes that got written since the last flush period on the wire. So with network attached storage like EBS, it is less, it's going to be more stable. It's going to cost you less. We're only putting out there what is really needed. Same thing with actually the storage, right? If you're paying for storage, there is less wasted space here. There's less defrag activity because we really fill the blocks all the way through every single time. And then, so we saw first thing, a big improvement in terms of stability and cost controls in people that want to deploy with, use EBS for storage. The other side is the max throughput actually increased too, Because if you were in 1 MB, 2, 4, 8 MB write blocks, you were far apart from the ideal size, which for most devices tends to be 128K. I think in EBS it probably is 256K, but either way, you can figure out what it is by playing around with it. We have stats that help you optimize there. So the nice thing here is we actually get a better max throughput for people that were already on larger write block sizes just by tuning it down. So this approach is better both on the low throughput end and the high throughput end. Um, and it opens the door for different deployment models. So first thing, if you were in memory with persistence, you don't have to use a local SSD in order to do persistence. You can do persistence to EBS, which is more readily available and, cheap and nice, right? The other thing is shadow devices. If you had a deployment, let's say with, which is basically says that for each device you assign a shadow device, tends to be that the local SSD will have a mirror to an EBS drive of the same size. And now what happens is if you lose that instance, you can just reattach its EBS drives to a new instance, and the data to the local SSDs will get filled over the wire, and now you basically are back in operation without losing any information, even though the instance with the local SSDs went down. And then let's say you wanted to do, and then typically that allows you to go down a whole AZ. So if you were in a 3 AZ deployment, you can actually do a 2 AZ deployment with shadow devices on EBS and get the same kind of durability with the cost of less machines. So that's another pretty nice deployment option. And the last thing is really, what if we had a customer that wants to do some things that are really high throughput, but also have low throughput use cases where they say, we're just doing a few thousands or 10,000 reads and writes per second, and we don't really need to do millions of operations per second. They can deploy now data directly on EBS, right? So the nice thing here is that EBS versus local SSD, sort of storage optimized instances, it's that those are more expensive and less available than compute instances plus EBS, right? That is much easier to provision. You can get you can kind of get almost whatever ratio you want between memory and disk, because the EBS, you can just kind of ask for however much you want. That's another nice thing, is that you're not tied to these pre-allocated ratios between cores, RAM, and disk. Right now you can control that. The next thing is, of course, the cost is lower, right? And we've seen in our own internal testing that things like IO2 give you really nice low latency guarantees. But if you don't have a lot of throughput, it's also pretty affordable. So we're really trying to just give a lot more deployment options. We have a really cloud native approach here that allows people to use persistent disk or local SSDs depending on their use case. And by the way, we are going to publish all this information that we've been benchmarking, and probably in a larger announcement a little down the road. But in the meanwhile, it just looks very good, and it all leans on these 7.1 like changes that we've just done. Okay, so that I feel like is like I said, you get better max throughput, even if your data on SSD and using local SSDs, you get much better cost and performance and better deployment options for low throughput situations. And it's just, another set of deployments that we know you can get very efficient results out of the system with Aerospike 7.1. So we feel very good about these storage related changes here.
And important to emphasize that AWS is just, their block storage service is just one example of, of platforms that we could support. There's a lot of testing obviously involved with calling them actually supported, but this isn't specific to AWS, correct?
Absolutely. I'm bringing EBS as an example. We are definitely going to do similar benchmarking on, Google Cloud, etc. We have customers that we know already use things like NetApp, right? So it needs to be, NVMe compatible, interface. But in general, this is going to mean the same for all the persistent disks of the different cloud providers, because they all kind of share that commonality. So yeah, we are doing a lot of this benchmarking in the EBS side of the world, but we will definitely dig in just as deep with other infrastructure providers.
Yeah, and the net is just more options for deployment, more options for cloud architects and for application architects and data teams to kind of choose the characteristics they need, and Aerospike gives a lot of options.
Definitely. Yeah, mentioned that several times, but the idea here is that you can have different namespaces that are configured different ways on the same hardware, or you can choose different instances and run Aerospike on all of them and get extremely good cost performance, right? That is really the secret sauce of Aerospike above all, is that is the database with the best cost performance of any database that we know of. And so if you both want to have really good throughput and latency, and you want to do it in a way that is the most cost efficient way possible, we give you a very wide range of storage media for the indexes, for the data storage, and kind of the same characteristics, the same inline compression ability, the same fast restart ability, and really leave it up to our customers to decide what is the correct deployment for different applications that they have.
Very good. I see we still have not gotten any questions, and I think we've covered the topic pretty well. So let's go to the final section, which is really a number of different changes that taken together we were talking about operational improvements. So can you cover each of these, Ronan?
Yeah, okay, so reviving dead partitions in an automatic way. So if you're in strong consistency mode and you have certain types of hardware failures, the partitions associated with the nodes that went down may be marked as dead. Now, a dead does not mean unavailable. It just means that we need a human to take a look at like what was the reason that this node went down, and then decide it's good, and then they'll send a revive command, info command in, and those partitions become available again for reads and writes. The other partitions will continue to work, normally as before, right? So um, however, the reason we've done this is like for something like Jepsen testing that we passed, it really is kind of like an A plus grade or an F. There is nothing in between, right? If you get something wrong, if you miss a write, or you get data inconsistent, you will basically fail the test. So we've passed it, but it's pretty pedantic, right? Like people that are deployed in the real world on a lot of nodes in the cluster just say, we know we have a lot of redundancy here. There is a replication factor number of copies in the system, and we might be deployed across 2 racks. So why don't you try to automate some of these things and just be less touchy, right? Like we're okay with a B plus instead of an A plus, right? We want it, we feel like it's okay. So we have basically added a config at the namespace level that allows a customer to choose whether to have some scenarios automatically revive, right? Those dead partitions. So it won't work if you actually lost data, right? If you have a drive that says, hey, I know that I've lost data, or I had a drive failure, that's not going to work here, right? Like that information is in there and they can choose whether they want to permanently take down the node or what they want to do here. However, other situations where let's say you lost a node in one rack and then, data migration started and then you lost a node on another rack. At that case, it's not like they went exactly down at the same time. And the operator might say, I feel okay, and I'm not worried about the very, very off chance of 2 nodes going down exactly at the same time. So when you see 2 nodes going down and I have replication factor of 2, then just, go ahead and revive them automatically for me. So we just kind of eased it for some of these situations. The other thing we did on the automation side is automated TLS certs being pulled from other sources. So in most of Aerospike secrets, you can choose how you want to store them. You can store them on the file system and protect it, with file permissions. You can store it in an environment variable, or you can have Aerospike fetch it from a secret management service like AWS Secrets Manager or Google's GCP's Secret Manager or whatever, right? There's different services out here, or Vault even, and we have the secret agent that the server interfaces with in order to go ahead and fetch those. If you kept your certs, your TLS certs on the file system, we would know automatically that you modified the cert and pick it up, right? Like pretty quickly, within seconds, we would identify that it changed. But we didn't have that for certs that were stored in a secrets management service. So now we have a config that basically controls the interval of how often we're going to check for a new cert. And then Aerospike will just pull down that cert from, through secret agent and apply it rather than forcing you to restart the nodes in the cluster, right? So it's just done in an automated way. It's very convenient. Next thing here is capacity planning. We added a budgeting system for the namespace to say how much memory are you willing to allocate for indexes, whether it's the primary index, the secondary index, or the SEP index. All of them can now have a memory cap that just says, when you hit whatever, 64 gigs, just stop writes at that point. Don't accept any more writes from the client. We're going to consider this thing full. So that's just one more capacity planning tool that is given, and it's especially convenient when you're doing in-memory namespaces, or if you're like in Kubernetes, for example. The next thing is just improvements along logging and metrics. Our goal is to always work on these things. Every release tends to have some improvements there, and it's just to allow our customers and support to close the loop on any type of incident much faster, because we have more information available for the support team or the SRE at our customer. On the security side, encryption at rest has been redone, driving down the CPU cost associated with it. We have, if you turn on role-based access control and you have a new node joining the cluster, that node, until it downloads the system metadata, SMD, from the other nodes with information about like all the users and the roles, it will only have the admin user for a short period of time. There's a default password called admin. So now you can set a different default password for these new nodes, so that you don't have some even potential of a malicious script to kind of like jump in and take over the node before the rest of the information got communicated to it. And then the next thing is relocatable RPM. So you can now use the -- relocate flag to have RPM put the files associated with Aerospike in different directories. And that can help if certain customers want to, let's say, install Aerospike on an EBS so they can rehydrate cluster nodes faster. That's one of the things that they could do. It's just one more option out there. So that's new in 7.1.
Wonderful. Well, that gets us pretty close to the end. I see that we still don't have questions. People are shy. That's okay. So just to give you some direction as to where you can get some more information out there, the three best resources that are just newly released with the product is Ronen's technical blog, and that goes into all the areas that we covered tonight with a little bit more detail. And also two developer-oriented blogs, one that discusses the new LRU cache eviction technology. Gives you a bit more depth there. And then second is discusses our storage IO feature that Ronen has covered. So besides that, there is the press release, and there's of course the product doc, and as uh, as Ronan mentioned, we encourage you to try out the product. We are, working hard to make it a fairly straightforward, easy, and enjoyable experience to try the Aerospike 7.1 product. And with that, do you have any final thoughts about Aerospike 7.1 for our guests,
Wait,
Ronan?
we actually have a Q&A. So wait, I'll do my my
Oh, look
final
at that.
thoughts, then we'll get to that. Okay, so first thing, I just wanted to let everybody know that I'm obviously biased. Um, and I would just suggest for people to download Aerospike and try it for themselves, right? We have a single node um, trial that basically, if you go and download Aerospike, the mode, like the container image or whatever, the mode it starts up with is a single node trial that has access to all the features. So, compression, all these things you can try for yourself. You can also go to our try now button, um, which is you'll see it on our website, and try now allows you to get a 60-day trial for an 8 node cluster. And again, you can deploy it and try it for yourself. And you know, if you wanted to try it as an in-memory cache or an in-memory database, I would suggest using it without a persistence layer even. You can define a persistence layer on disk for the in-memory system, but now they're mirrored one-to-one. We almost don't use the disk for anything at all. We don't use it for defragmentation. We don't use it for the tomb rating, the tombstones that are associated with durable deletes. It is 100% there for persistence. So only when you restart the node under certain conditions, like say a crash, if you're in memory without persistence, even a crash will go directly out of the in-memory data storage, right? So it's very interesting to try it in that situation. You can try it with compression turned on and see what happens. You can tune the low water mark configuration parameter and raise it. By default, we kind of like leave 50% available for defragmentation. But if you're in memory without persistence, you don't have a disk you have to worry about here. You can just basically go and slowly raise it from 50% towards 66%, take a lot more, and you're basically sacrificing a little bit of CPU for more space utilization. And we've done it in demos and things like reInvent. And what I suggest is to just try it out and see how much memory impact or CPU impact is there when you start increasing this. So you can squeeze more with compression and with tuning the low watermark to use more and more of your memory storage for actual data. And that would be is kind of fun to try out. And you can, take down a node in the cluster, restart it, see how fast it comes back with all the data on it. So I would suggest that. Okay.
Very good. Well, that actually does address the question that has come in from Louis Chalam. Sorry if I get that wrong, but he or she is a DBA managing our DBMSs, trying and would like to evaluate Aerospike. So we have the sandbox. You can there's the try now that you mentioned. What would be your first step if it's a seasoned database administrator wanting to check Aerospike out?
Yeah, so if you go to aerospike.com slash, I think it's slash developer, the developer hub has actually a sandbox where you can just kind of, bring up an instance in the background, and you can type directly into the browser in order to write code, to use tools, command line tools, and all that stuff. So that's pretty fun. The next step beyond it is just to grab a container image, with Docker or whatever you use, and deploy it and play around with Aerospike directly there. We also have training. So if you do try now, you actually will get like an email that will give you resources, will give you access to training, and all of these things are pretty useful ways to go. The developer hub also has a lot of like um, Jupyter notebooks and a lot of like kind of training like walkthroughs. So
Tutorials and
tutorials and all that. So I would suggest that. And yeah, there's a lot of training resources out there for Aerospike, and I would play along around with it. You can obviously, if you're interested at any point, you can also contact us and talk to, one of our sales engineers that can just, discuss your use cases with them. Um,
Or also, we have our developer relations team that has written a number of developer-oriented blogs that might be useful as well. So I think that covers Louise's question. Any other? Krishna raised his hand. I don't see a question. Can you type one in if you have a question? We're just about to end the webinar, but if there are any other questions, I don't see any. Well, I think that's going to do it for tonight. And anyway, want to thank everyone for joining us. This has been the Office Hours webinar with Ronen Botzer talking about our Spike Database 7.1. We hope that you will try it out, evaluate the product, and if you have any questions, please don't hesitate to contact us, and we'll be happy to answer any further questions you might have. With that, we're going to end the presentation. Ronan, I wanted to thank you for your input and everything you've taught us today.
okay, no problem. That was good.
All right, everyone. Thank you very much for joining us. And that will conclude our webinar for today. So